Hi everyone, welcome to this channel. Uh, Today I want to talk about the yield keyword in Python. Uh, this is yield keyword is really really interesting keyword because it is related to iterables, iterators, generators. Uh, all these concepts are pretty important in Python. So first of all, you in order to understand the yield keyword, you need to understand the iterables first. Uh, I assume that you have some experience with Python, and you have write like 1,000, 2,000 lines of Python code. So you know lists, sets, or something like that, elementary concepts in Python. So let's talk about iterables. Iterables is a kind of concept or class, or we mean meta class or something. Mm. It has to meet some requirements. Uh, uh, I mean, you can you know the requirements from its name, iterable. It has to be iterable, right? So, uh, list is iterable, and tuple is iterable. Set is also iterable. Uh, there are some properties of iterables that are important to remember here, because we need to compare iterables with generators and with yield statement. Uh, Iterables, all elements are stored in memory. That means every time you put one more element into an iterable, it will take up some memory. So and second, you can iterate over iterables multiple times. Let's see how that goes. First, we define an iterable L equals 1, 2, 3 equals a list. Here we iterate over L two times. This is the first time. This is the second time. You can see that we can iterate over L multiple times. We can even iterate it over a third time. There is no problem. Okay, so we move to generators. Generators generator is a little more a vague concept that is difficult to understand. But here we do not define generator or all its properties or meaning, but we define it simply as a, a function, a function uh, that first of all, generator is not a function. We define it as a result of a function we, in, in which uh, uh, we used the yield keyword. Let's say and there's two properties of generators that we need to consider here, because we are compare generators with iterables. The first is that generators generate items on the fly. Uh, you can compare this with iterable, the first property. And the second, you can only iterate over generators once. You can also compare this property with the property of iterables. You can see the difference. These two properties are pretty important. So here we defined a function exponent 2. Uh, uh, you you can read this code. I don't think I need to explain it. You don't need to worry about the yield keyword for now. The actually this line is the same functionality, but we do not need it anymore. Mm, uh, L2 equals exponent 2 and L. First, let's say what is L. Insert cell above. Right? L is a list with items 1 to 3. So uh, 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 L2 equals exponent to L, and let's see what happens here if we execute this statement. Say L2 is a generator object. Is a generator object. So the generator is a result of a function call, in which function there is a yield keyword in it. And let's say, and at this time, at this exact point, there is no element we can access from L2 because it has not been generated yet. If you want to access the elements which will be generated, you need to use a for. Every time you can use for to let a generator to generate its items. And the second property, you can only iterate it once. You can see that here it resulted, its result is like what we understand, right? 1 2 3 1 4 9, right? But the second time you iterate over a generator, there is no result here. There is no result returned generated from that generator anymore. That is the property. You can only iterate it over one. You can only iterate over a generator once. The second time or the third time you iterate over it, there will be no results. And here there is. I will try to explain why is that. Why that property exists. So let's say we define L2 again, and let's say what it is. Okay. There is a keyword in Python next, which get an iterator's next item. So let's say what will we get from next L2, right? That's interesting. What if we get a next element? Interesting, right? Okay, let's see what next. Oh, 149, all of the items. You say after all the elements have been generated by the generator, the last time it will raise an exception, which is stop iteration exception. You might be wondering why while we using for to iterate over a generator. There is no stop iteration exception raised. Actually, the for keyword will capture that exception, stop iteration exception, and it understands this keyword. It understands that there is no more element in 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 here anymore. So this as exception is captured by this keyword. And last, we get to the yield keyword. The yield keyword is a yield is just a keyword that is used like return, except the function will return a generator. Uh, mm, Here, let's say a function defined like this. Mm, it is a little more it is a little difficult. Let's simplify it. Just yield 1. Okay, let's say L3 equals func for x in L3 print x. Here, you actually, but there is a difference here. If you use return here, the L3 will be just 1. It is not iterable. Let's say what that will happen, right? Int object is not iterable, right? Okay. The yield. In order to understand the yield keyword, we have to understand how this function works. First, L3 equals func. At the first time the func is called, nothing is executed in execution inside func. Now we can say that after we call the function, I defined it as func, right? After we call the func, nothing will happen actually. It just returns the iterator. Let's see. Right? This statement or expression, I don't know that difference. We do not care about that. This statement is not executed at here. Right? Only after you started iterate over the generator, the function actually gets executed. And what if we yield multiple items? What if we yield multiple items? Here is something interesting. Yield I. Sorry. Here is something interesting. The first time you it is a little difficult to explain it. The first time you call next L3, it gets executed once. It gets executed from here and then here and then here. After the execution process hit here, it will return a result. The first time it returns 1, right? But what about the next time? Okay, here you can see that there is this statement is executed at here. What about this time? Will the function print this again? Think about it. Will the function print this again? Okay, let's see the result. You can say that this expression this statement was only executed once. How did that happen? Actually, after the first time the yield executed, which is the first time you call next L3. After the first time it yield a result, the function stops at here, exactly where here. The function stops at here, but all the environments or the variables, all the environments are reserved. The next time you call next on a generator, it starts execution from here, right here. The last time it stopped, right? The yield keyword return a result, and the function is not dead, and it stops just here, and all the environments, all the related variables or everything is reserved. The next time you call next, which will let the function starts from here instead of from here. Understand? Thank you everyone. I hope I made something clear. If you still have some questions, you can use the best teacher in the world, which is Google. In this, actually, I learned everything from Google. I started learning Python about 5 years ago. Everything I learned is from Google and Stack Overflow or something like that. Thank you, everyone.